Welcome to Notes 17-2, Day 2. We're still on directed line segments. And this is page 248. Page 248. It says another way to solve partitioned segment problems uses visual modeling and similar right triangles. So just to refresh your memory, similar right triangles. So for example, if you have a triangle ABC, and another triangle DEF. The triangles are similar if you can either have side angle side similarity, side similarity, or the one that we generally are going to be using is called angle angle similarity. If you have two pairs, there's one pair, two pairs of corresponding congruent angles. So for example, angle A is congruent to angle D, and angle B is congruent to angle E. To angle E. Therefore, the triangles are similar. Triangle ABC is similar to triangle DEF by the angle similarity. All right, that means that AB corresponds to DE. That means that BC corresponds to EF. And finally, it means that AC corresponds to DF. So if you were to take any two corresponding sides like AB and make a ratio of it to its corresponding side, DE, that will equal the ratio of BC to EF, again corresponding. And finally, that will equal the ratio of AC to DF. These will all be equal, these ratios. Okay, so it says, find the coordinates of point P that lies along the directed line segment from A is 2, 2. So I'm going to graph that. A is 2, 2. And B is 10, 8. 10, 8 is right here. And I'm just going to triple check. Yes. All right, so to do that, it says that they want us to find the point P that partitions the segment into a ratio of 3 to 1. It says to graph points A and B on the coordinate plane, which I've done, and then connect the points. So I'm going to connect points A and B. And it says to estimate where I think point P is located and plot that point. Well, I can do better than estimate. If it's in a ratio of 3 to 1, what's going to happen is that 3 to 1 ratio is going to divide this line segment into 4 pieces. 4 pieces where 3 of them will be from A to P and 1 of them will be from P to B. So if I were to find the slope of this line, which the slope is rise over run, I rise 6 units, so delta Y is 6 over, I run 8 units, so delta X is 8. And I could simplify this if I wanted to, but I don't need to, because remember, what I want to do is divide this rise and run into 4 segments. You don't have to do it this way. You could also count from one hash point to another hash point. Like if I go up and over, I'm on a little mark. If I go up and over, I'm on a corner. If I'm up and over, I'm on a corner again, and you can see that I've just partitioned it into 1, 2, 3, 4 segments. So I know that A to P has to be 3 times from P to B, so 3 to 1. All right, or you could have divided both of these values by 4 because we want a 3 to 1 ratio, meaning that I'm going to create 4 segments. And that would have given me 6 divided by 4 is 1.5 over 8 divided by 4 is 2. If I go up 1.5 over 2, you can see I'm at a hash point. Up 1.5 over 2, up 1.5 over 2, and so on. So I know that point P must be right here. All right, it says draw a horizontal line through point A. So I'm going to draw a horizontal line. I can see the 2 triangles I'm going to be creating, but they're trying to guide you along to it. So I'm going to draw a horizontal line through point A, and then it says to draw a vertical line from point P and from point B. And I can, oh, I need to go one more unit. There we go. And I can see my two similar triangles. I'm going to call this point C and this point D. And so I have triangle ACP. I have triangle ACP. And I have triangle ADB. Triangle ADB. All right, so what I know is that the ratio of A to P will equal the ratio, the ratio of AP to AB will be equal to the ratio of AC to AD, and so on. All right, they want us to find the length of AB. So the length of AB is the distance from A to B. I'll remind you that A was at 2, 2, and that B was at 10, 8. So I'm going to use the distance formula. It's going to be 10 minus 2 squared plus 8 minus 2 squared. And that's 8 squared plus 6 squared, which is 64 plus 36. And the square root of 64 plus 36 is the same as the square root of 100. And the square root of 100 is 10. And now, since it's a day off, I'm just going to triple check that 64 plus 36 is 100, and it is. All right. Now they want me to calculate the length of AP. So P is at 8, 6.5. So P is at 8, 6.5. So we're going to do this time P with A, square root 8 minus 2 squared plus 6.5 minus 2 squared. So that's 6 squared plus, whoops, I forgot to write my minus 2. Minus 2 squared. 6.5 minus 2 is 4.5 squared. 4.5 times 4.5 is 20.25. So this is 36 plus 20.25. So plus 36 is 56.25. And the square root of 56.25 is 7.5. All right. Now I can confirm. Oh, let's see. Where's the next page? Page 249. Page 249. All right, this is to draw and label the two triangles. Label the hypotenuse of the smaller triangle from the value in part D and the value in the larger triangle from part C. So that's the two triangles that I've already drawn. Triangle APC and triangle ADB. And remember that AB is 10 and that AP is 7.5. It says to write and solve a proportion to find the x coordinate of point P. Well, before I do that, I actually just want to show you one thing. So I want to show you that if I were to take the ratio of this side, 7.5, over its corresponding side, which is 10, that should equal AC. The length of AC is from 2 to 8, so that's 6 over the length of AD, right, which is 8, and that should equal the length of CP. CP is from 2 up to 6.5, so that's 4.5, over the length of BD is from 8 down to 2, which is 6. And if I divide any of these, 6 divided by 8, whoops, excuse me. So 6 divided by 8 is 0.75. 7.5 divided by 10 is 0.75. And finally, 4.5 divided by 6 is 0.75. So you can see that these three ratios are indeed equal. Just as I said earlier, that's what would happen in similar triangles, right? That these proportions will be equal.